question from circular motion. Okay, where in the question it's given that a car is rotating on a circular path. It's just turning, taking a turn, not rotating, basically taking a turn on a circular path. And the radius of this circular path is nothing. Let us say if this is the car, okay, if this is the car standing in front of you. Let me zoom a little. Yeah, I think it's better understandable now. Yes. Now, if a car is to turn around a circular path, it must experience a centripetal force for this purpose. Okay. And the question which is given to you is that a car takes a circular turn of radius 20 meter. So from here, you can see the radius of this circular track is r is equal to 20 meter. Let us collect the data as given to you into the question. This is the data given to you, r equal to 20 meter, right? And the car is at a speed of, the velocity is given for the car, that is 54 kmph, that is 54 kilometer per hour, right? This is the speed of the car which is turning. This is the car which is just going through the circular track. Okay, this is the car, right? Now, what is the least coefficient of friction between the tire and the road that can prevent the side slipping? If the car is just going and turning through the circular path, okay, then definitely there will be some force which, that if the velocity of the car will be higher, then this car can overturn. That's why if a car is to turn around a circular path, it must experience a centripetal force for this purpose, isn't it? The centripetal force, right? This centripetal force is provided by the friction between the tires and the ground. Okay, this centripetal force is provided by the friction between the tires and the ground. So few tires are attached over here also. Okay, so this tire and ground. So tire is here. Okay, let us say tire is here and this is the ground. So from here we get the centripetal force, which prevents the car for skidding, right? So here this centripetal force is provided by the friction between the tires and ground. This is the tire and this is the ground. Okay, and this centripetal force is provided by the what? By the friction. Friction between whom? Friction between the tire and the ground, which is lying over here. Okay, this is the track of the car. Okay, the tire are on the road, so between the tire and the ground the friction will be there, and this friction will provide you the centripetal force, right? Now, if the centripetal force required for the circular motion is more than the maximum friction force possible, okay, the maximum friction force possible, then possible between the tire and the ground, okay, there will be a tendency for side slipping. Okay, the tire can slip and go out of this track, right? So let us draw the free body diagram over here. If this force is F, right, then here towards the internal track there will be a, so this is not up to a scale, let us say center is somewhere over here. Okay, so this will be mva square by r. Okay, okay, this will be mva square by r. Now there will be normal reaction for the car, which is due to the car is standing on the ground or running on the ground. This will also have some normal reaction. Let us say it is r, and the weight of the car, which is lying downward towards the ground, under the ground, in the direction of under the ground, that is equal to mg, right? Now r on the normal reaction on the top, mg on the bottom, and mba square into the right, and this f as we discussed, right? Now The forces acting on the car are how much? This is the force on car are its weight, that is mg, this one mg, right? Number two, what is other force acting on the car? That is resultant upward force due to the contact force. This is the normal reaction R, right, by the ground and the wheels, right? And the frictional force F directed towards the center of the circular path, right? So this is frictional force F, right? Now the fourth force which will be acting over here is what? Let me write over here. Fourth force is centrifugal force mv square by r. This one. So basically this turn which I have posted over here, actually this track, the car is turning over here. Okay. So the slope of the track will be like this. Okay. Like this. And the mv square will be mv square by r is the centrifugal force. This is centrifugal force which is just exhibited, centrifugal force which is exhibited outside the track. Okay, and inside the track you are kept on the track. This car is kept steady on the track due to this force F, that is the centripetal one. Okay, the centripetal one. So regardless of the movement, just understand the position of the car and what are the forces acting on it. Okay, so the forces acting on the car are mv square by r, the centrifugal one. Okay, and then F, the frictional, due to the friction of the between the tire and ground, this is the centripetal force, right? And then the normal reaction and this one. So from here, let us say that there is no vertical motion, right? Then we can say R is equal to mg. Then R can be written as equal to mg, isn't it? If R can be written as equal to mg, then the maximum frictional force F, maximum frictional force F, this frictional centripetal force or the frictional exhibited by the friction, and this is F, right? This maximum frictional force equal to F equal to mu n. Mu n means mu is the coefficient of friction that which we need to calculate, and n is the normal reaction. So let us say m mu into r, and since r equal to mg, we can write the frictional force as mu times mg, right? This relation can be written, right? So for no slipping, what we can say that this F should be equal to mv square by r, right? That means F is equal to mu mg should be equal to the mv square by r. This centrifugal force should be counterbalanced by this frictional force, right? So this will happen at this condition. We need to find the value of mu, right? Now you can see over here the mu, the value of mu can be here, m and m will be cancelled, and the value of mu, the coefficient of friction, is given by this v square by r, which is already present over here, and this g will also join this r into the denominator. So v square by rg is the coefficient of friction, right? And what is v square by rg? V is 54 kilometer per hour, you can see. And if the value of v is known and the radius is in meter, so just convert it into meter per second, right? So when you multiply 54, convert 54, right? And convert 54, just multiply 54 kilometer into meter will multiplied by 1000, 54 into 1000 meter. and it's hour 1 hour is 60 minute and 1 minute is 60 second, like this, right? So two zeros will be cancelled, so 36. So from 3 18 times, 3 2 times, 3 6 times, 3 2 times, right, 60 by 4. So this is coming as 15. 54 kilometer per hour is 15 meter per second, right? So just over here you use the 15 meter per second, right? So the coefficient of friction will be 15 into 15, right? Because velocity is square divided by r. What is the value of r? This is 20 meter. 20 into the value of g, that is 9.8. Just solve this, okay? Just solve this to get the coefficient of friction, okay? The minimum coefficient of friction which stops the car to slip, right? So this will be, on solving you can see 5 3 times 15, 5 4 times 20, and then 3 into 15, that is 45 by, so just solve this to get the value of mu, okay? Just solve this to get the value of mu and you will get it, okay? 15 into 15 by 20 into 9.8. I'm not going into the arithmetic calculation, students. Thank you so much for watching. Take care and be connected. And for any query, you can put up into the comment box. And for any specific doubt, you can reach out to me. Thank you so much. Take care. Bye bye.